and today we will be covering the writing session mainly, but before that, I would like to touch a little bit on the RevMan and the interpretation of the forest plots because you can't write results if you don't know how to interpret the forest plot, right? So this is RevMan, which is called Review Manager. My version is 5.4.1. You need to know this version. Why? I will tell you later. So when I open this RevMan, okay, before that, let me touch on this part. Do you guys remember that we had this sample sheet in our last data extraction session? And we extracted data for one study, and like I extracted one part and you guys extracted the other part. We extracted data for the continuous outcome in mean st format, and we extracted data for the binary outcome in the events and total format, right? So what I have done is I have created this hypothetical data set for B, C, and D, and to basically teach you how to do the analysis part. But before we go into that part, there are few mistakes that beginners make, and I have made those mistakes in these data sets. So I want you guys to pinpoint the mistakes that I have done in this data set. And what I will do is I will choose these 4 data sets, and I want you to tell me, do you guys see a difference in these 4 data sets? And if you do see a difference, then I want you to tell me what's the difference. Yes, study D data is different. So I didn't open any study. This is one art I would say that you have to learn, is that talk to the numbers. And if you are listening, they will talk back. So if you look, there is 40.55 here, 40.77 here, 40.67 here, and 101 here. So this is something we call an outlier. And when you see this in your data sheet, you have to go back to the study and check what's happening here. Because this is a hypothetical data set, I don't have any study, but I will tell you what's happening. So this 40.55 value is in the centigrade, because this is the fever outcome. We can check the fever either in centigrade or in Fahrenheit, right? So in this data set, all these 3 studies have reported data in centigrade scale, but this one study 101 has given us data set in Fahrenheit scale. So when you are extracting data, you have to pay very careful attention to these small things, because if these small things are wrong, then your whole statistical analysis is wrong. So what I like to do is I like to add these comments right here. So when something is different, I will just type in that, hey, this is Fahrenheit and not the centigrade. And other comment we have is data on row 20, is it average of data on row 20? Okay, so no, ignore this for now. We will just pay attention to this. Okay, so and another thing is, if you guys pay attention to this row, other than this 10.5, do you guys see a difference? This is 10.5 because this is Fahrenheit. We already figured that out, that hey, this is 10.5 for the Fahrenheit. So what I have done is I have, like, again, this is hypothetical data. I have converted Fahrenheit to centigrade, and what I can do is I can delete this data and then put in this centigrade Oh, yeah, centigrade data. Remember when we were in schools and they told us that, hey, if you want to add centimeters with meters, you either have to convert meters to centimeter or centimeters to meters, and then you can add them. Same goes for analysis. You either convert all these values into Fahrenheit or you convert this Fahrenheit value into centigrade. So in this case, because we have three studies in centigrade, it's convenient to just convert this one study. I will do that. And other thing, can you guys notice any difference in this data set? This is another mistake that beginners do most of the time. Can you pinpoint it? Yeah, study C. So what's the difference? Yeah, what's happening is that we have data here as 1.31, 1.5, 1.4, and this is the only one that's in 0.15. So this tells me that, hey, something is wrong with the data set because this is not consistent. So what's the problem with this data set is that this value, this study C, has given the data set in standard error format and not the standard deviation format. When we were looking at the tables and we were saying that, hey, we have to pay attention to mean ST and we have to pay attention to months. So in this case, what the study has done is they have given us standard error instead of standard deviation. Why I'm putting this here? Because when we do the analysis, we actually have something and we can use that to convert this standard error into standard deviation. Same rule applies. You cannot add centimeters with meters. You have to have a uniform unit. Same goes for this. You have to have a mean ST and you have to have all in centigrades. Another thing happens is that sometimes they give you mean and then they give you confidence interval. They don't give you ST. So we have a solution for that as well, and all of those solutions are in RevMan. So now I will open the RevMan. When you open the RevMan, this is some homepage that you will get. All you need to do is add the file and new. Click next because we are doing interventional study, right? We are doing the comparison, acetaminophen versus ibuprofen. So this one stays, and here you can type. This is for your own convenience. So like I can type in whatever for now because drug A for health problem B. So this is not a protocol, this is a full review. So we will finish that. And now you see how I have a drug A for B health problem. So this is my review. First thing I want to do is I want to go to, hey guys, can you see my RevMan, right? Yeah, you can. So first I will go to this studies and reference. I will double click this. I will go to this references to the studies. You see these keys. You can click these keys to open all your options, or you can double click this. So I will go to this included studies option. I will left click it and then I will add studies. In our case, our studies are named study A. Most of the time these are the authors names, but we are doing a hypothetical set, so it's study A, and I have put in the year as 2000. This is their example. Like you can, they are naming the study as Cochrane, and the year can be 2007. If you don't add the year, they will ask you when you move to the next page. See how I wrote the 2000 and now they have filled it for me. I will finish this, and just like that I will add all the studies. Study B, let's make it 2001. I don't need to do the whole next thing because I've already added the year, so I will just finish. Study C, 2002. study D. Let's make it 2007. So now when I click this key, notice how I have all the studies. Guys, I will answer your questions maybe at the end, because what's happening is that when I get the notification, I'm like reading that, and this breaks the continuity, right? So once I'm finished with all of this, we can take in the questions. So notice how these included studies are in this and right under this part. And now I will go to the data and analyses, and then I will double click this, or we can also not double click. First I have to add something, right? So if I left click, they will give me the add comparison. Again, you can write it for your own convenience. This is something that only you will be able to see. I can just write in acid versus IBU. I will tell you where you cannot write short forms. For this one, I can write it, but for other case, I can't. So acid and IBU is right here. And then what I will do is, our next option is to add the outcome. I will add the outcome. So this is where they ask you, do you want to do the dicot or do you want to do the continuous? In this case, our is mean ST. See that they are telling you that, hey, for continuous data, you will have to add the mean and ST and number of participants, and we extracted data in this format. We did mean, SD, and total. So because our fever outcome is continuous here, I will add continuous, and then I will name my outcome, which is fever. And right here you have to write the full forms: acid aminofen versus ibuprofen, and then we will click next. So these are the statistical methods that doctor was telling you yesterday, and these are something that biostatisticians are heavily involved with. For at my level, I only want to know what's important for my project, and I don't want to go into details of these until and unless I want to do a biostatistician's course, right? So for continuous data, they are telling me that, hey, you can only use inverse variance. And regarding this fixed effect and random effect, so these are the analysis models. And fixed effect model assumes that there is no, all your data sets are homogeneous and there is no variance within your studies, which is rarely the case. So to avoid any conflicts, we choose random effect, because random effect assumes that, hey, our studies may be a little bit different. So in that case, that's why I'm choosing the random effect. And for mean difference and standard mean difference, we pick mean difference when we have units. If they have given us units, in our case they have given us the centigrade, Fahrenheit, so I will pick mean difference. If they have not given us any units and they have just given us numbers, in that case I can use standard mean difference. So for our case, I will pick this. Click next. These are some default settings, and with this default setting you click next, and now this is where you have to type in your full forms, because these will be showing in your forest plots and you will be sending those forest plots to the general. So it is recommended to type in the full spelling and right spelling. Acid amino, and then we will type in ibu, and then I click next, and now they are giving me a bunch of options, but I will show you these from this bar. So for now I will click nothing, finish. When I click this key, notice how I have a fever outcome in under this acid IBU study. So now what I will do is I will add the study data. You see, when I open this, when I double click this, we have nothing here. We just have we just have this fever right here and no studies. So first I need to add these studies. So I will click this add study data, and remember the studies we added right here, all of them show up now. So whatever studies I want to pick, I will click Control CTRL in my keyboard, and then I will pick all these and then finish. So now all of these studies are added right here, right? What I need to do is I need to go back to my data set and copy paste. Okay, so because we have this standard error right here, first we will need to, you know, fix that, and then we can copy paste the whole thing. But we have, to be honest, when I started, my mentors never told me that we have a calculator, and ever since I have discovered this calculator in RevMan, my life has been so much easy. So what happens is that in this calculator, you have to give this calculator only 3 values, and the rest in this whole line will be calculated. So in our case, let me minimize this so we can see some data sets. Let's do it like this. Can you guys see it? So now you see I have the mean. I have the mean for 40.67. I will type in that mean 40.67. And then N1 is my total number, which is 100 over here. I will type in 100. And then ST is the standard deviation, SE is the standard error, CI is the confidence interval. You will always be given 2 values for 95% confidence interval. So you can put those. These I have never used. So for standard error, I will type in 0.15. So when I click anywhere, the whole row gets filled. So my standard deviation is 1.5. I will type in 1.5 right here. And I will repeat the same for this because this is 0.13. This will be a standard deviation of 1.3. And now I can copy paste the whole thing in here. So with copy paste is I sometimes the copy paste doesn't work, but this is what happens when you select all these, and then you will click Control V, and then because when you left click, the paste option doesn't show up. So if you select all of these and then click Control V, then you don't have to type in every individual value, and this will be copy pasted. Now we will try to interpret what the forest plot means. So you can use this scale. When you send the forest plot to the general, you have to send them a pretty version. So look how in this version you cannot interpret anything. Or when you make it this also look ugly, you cannot see the diamond. So this is also not a good version. The pretty version will be where this diamond looks good. So the shape is not neither too stretched and neither too small. I would call this a beautiful plot for vision purpose, right? So now when I click this button right here, it gives me the forest plot. When I click this button right here, it gives me the funnel plot. So for now, for our discussion session, we will try to understand this forest plot. So because that was a lot, let me know if you guys understood it. So look, this mean ST and total part should be like clear. Up until now, this study part should also be clear. Ibuprofen mean ST total should also be clear, because this is exactly what our data extraction sheet looked like. The only difference is this part right here, this, and this part right here. So before we dive deep into anything else, I want you guys to know something that's called significant and non-significant. When I say our results are significant, I need to tell what does that mean to you guys. The journals know what's significant and what's not significant. When I say significant, it means that the values are supported by the numbers, and they are not just by chance. So significance is checked by something. We have like 1, 2, 3. We have 3 ways to check the significance. First of all, you see this central line and the 0. So this is our mean difference. IV is the inverse variance that we picked, that the model told us to pick. And then we picked the random effect model, and we picked 95% confidence interval. This I'm emphasizing because what happens sometimes is that you find these random projects on LinkedIn or through colleagues or via anyone. They give you forest plots, and they tell you to write the result, to write the method section. So in the method section, you need to mention all these in the statistical analysis part. And so you need to know how to read this. IV's inverse variance, random effect model, 95% confidence interval. No confusion up until then. Then you see this line. Actually, you have to pay attention to this 0. If anything crosses this line or crosses 0, that is not significant. And on, if you see a line on this side not crossing this line, then that's significant. Anything on this line not crossing 0, then that is also significant. Let's look at the numbers. And what I mean, you see this number minus 0.11, that is the mean difference. And you see the values in this bracket, minus 0.39, 0.17. This is the 95% confidence interval. This is where it starts. This is where it ends. Suppose you were not given this value. You see this green is square. The size of the square is this weight, and then this line starts from here to here. That's the confidence interval. And this green dot is at the minus 0.11. So if I go down, let me put that pencil. We have the pencil. Oh, straight line is gonna be a challenge, but let's try. Oh, dang. That's not straight. So you see, if I go like this, then this will be minus 0.11 value. And this, if I pick the end of this and end of this, then this will start from minus 0.39 and it will end at 0.17 right here. And you can clearly see that it crosses this middle line. So I can say that study A did not have any significant values, meaning neither acetaminophen group, neither ibuprofen group was favored. Is that clear? And also, if you look at this value 0.39, minus 0.40, 41, 42, 43, this eventually crosses 0. And you will have to learn how to read these numbers, not for like this research purposes only. If you're appearing in USMLE or anything, they make a very big deal of these numbers. They will give you just these numbers and then bunch of options in the option section, and you have to pick if what's significant and what's not significant. Simple way to tell is for mean difference. Things will be a lot different for odds ratio and relative risk. This you have to remember 0 for mean difference. If you forget everything from this lecture, remember 0 for mean difference. It will help you when we move forward. So minus 0.39, 0.17, this crosses 0. Is that clear up until now? How do we extract that? Yeah, that's next. You know, I am doing the continuous outcome for now, so pay attention to this. The binary will be next. I do have an imaginary hypothetical data set for that as well. So repeat the, yeah, so this is zero, mean difference and zero. You have to remember that, because when we move to the dicot, there here you will see one, and here you will see risk ratio or odds ratio. So for mean difference zero, if it crosses zero, this data set is telling you that I had minus value and then it changed to plus value. So meaning it crossed the zero. In this one, 0.45, 1.09, we never crossed the zero. In fact, we picked above zero. 0.45 comes 0.1, 0.2, 3, 4, 5, and so on. So we started from 0.45 and then we ended to 1.09 and we never touched zero. So this value is significant and it favors the ibuprofen group. Same goes for this. We started with 0.08. 0.08 will be somewhere right here. We never touched that line and we ended at 0.86. We started with 0.54. We ended at 1.06. We never touched this line. So again, the results for these three studies were significant. And for this one, because this crossed zero, the results were not significant. This is something that's called the pooled analysis. And this is what we report in our results. And this is the diamond that tells you the significance or not significant. Basically, you can tell the significance from this mean difference, this diamond, and then this p-value. We will talk about that in a minute. So notice how we have 0.48, 0.03, and 0.93. Notice how this is just borderline to zero. You know, zero, first we get 0.01, 0.02, sorry, 0.00, 0.01, 0.02, and then we come to 0.03. So notice right here how the diamond is so close to the line, but it's not touching the line. So again, we can say that our results were borderline significant, favoring the ibuprofen. Borderline is your decision if you want to pick, you want to, put it in your results or not. But I personally would, because this will give a good picture. And now, because we have talked about mean difference, we have talked about this diamond, we will lastly talk about this p-value. So p-value, there can be like 3 or 4 hours discussion on this. What you need to know is that p 0.05 is the limit. If you have values less than 0.05, that's significant. If the value is above 0.05, that's non-significant. And other thing is, what it means is that if your value is, in this case, our value is 0.04. So what this means is that it tells me that, hey, there is a 4% chance that these ibuprofen favoring part is by chance. So that's a very less chance, and I can rely on this. But let's say if our P was 0. Let's say 52, so I cannot say these results are significant, because P is saying that, hey, there is a 52% chance that your results are by chance. And I can, if there is a 50% chance, then I cannot rely these numbers, right? So this is how you check the significance. First, you look at this pooled difference. It's telling us that this is crossing zero, just crossing zero. This diamond is also so very close, and this p is 0.04, which is again close to 0.05. So this is how we can interpret the forest plots when it comes to the significance. And another thing is heterogeneity. And we have this tau, chi, df. The only thing that you are going to report in your results is this I2 statics. And this basically, what is heterogeneity? So heterogeneity is something that tells you that, hey, whatever studies that you have picked, there is, if is there any variability among those studies. So if the hetero is, let's say in this case 89, we can tell that, hey, there is a lot of variability within these study groups. So what's the variability? Again, you have to go back to your pico and say that, hey, maybe within these four studies the population age varied greatly. They had, let's say, because it was done in kids, so I can say maybe they have uh, kids from 6 months to 5 years. So their, physiological body mechanism to cope with fevers are different. So if that's a broad population, I can say that, hey, maybe the variability is coming from that age group. And then I can say that intervention and control, maybe the dose for the acetaminophen was low and ibuprofen was high. Maybe that's why ibuprofen was working and acetaminophen didn't work. So that's another possibility in the variability. And then the outcomes, but we already fixed the outcome part. What happens is that sometimes you have different definitions for outcomes. We have PICO, and if PICO in our eyes it matches, but when we do the analysis we get very significant heterogeneity. We have to go back and check, hey, where is this variability coming from? Is it P, is it I, is it C, or is it O? So if let me give you a range for heterogeneity. I think 0 to 25% is mild, 25% above is medium, and then 50 above is high. Some numbers, some fancy numbers like that, I have put those in my word doc because I knew I will forget it. So in this case our heterogeneity is high, but question is what we do to address this heterogeneity. Because if our heterogeneity is this high, even if our results are significant, we cannot rely on them because there is very much variability in our data, in our studies. So what we can do is we can do two things. At beginners level we do two things, but biostatisticians do a lot of fancy things. So let me erase this first. Oh, in interpretation, this is like the last part that I have missed. So you see this total 614 and 614. This is the total sample size that you also have to report in the result section. So in the result section, we have this study part reporting, and then we have this pooled analysis part to report. We have these sample size to report. Heterogeneity is a must to report, p-value, and that's it. These things go in the results section, and then these will go into the method section. And when I write, you guys will understand what I mean. So we will remove this. So how do we address the heterogeneity? There is something that's called leave one out analysis. As the name implies, leave one. So we are leaving one study out one by one. So in this case, when I remove this, I will just click this, and the heterogeneity becomes 3%, and the weight for this study becomes 0%, meaning this is removed from the analysis. Now notice how our results became more significant. They were like, P was like 0.04, now it's like 0.00001. So it's saying that, hey, there is like, I would say 0.001% chance that this is by chance. And we can rely on these studies, on this analysis more now, because not only our results are more significant, we have less hetero. There is this common practice that students do, at least one of mine did. they removed like 2 studies because they removed all one by one and they couldn't get the hetero out. So what they did is they removed 2 studies at the same time. That's the wrong thing to do. Like if I remove like 2 studies at the same time, let's say I removed study A and study C, my hetero became 0, so that's better to report because 0 is better than 3%, right? But this is the wrong practice because as the name implies, you have to leave one study at the same time, right? So when I did leave one out, I had 3 hetero, but just because I have 3 hetero here does not mean that I will stop. I will do the leave one out one by one for every study. And the A is the only study that gave me 3% hetero, which makes sense. You see how this was the only study that was not significant, and when I removed it, it became significant. Let's assume we did the whole leave one out analysis and we did not get any change in this heterogeneity. So what's my next step? My next step is to do a subgroup analysis. So for subgroup analysis, I have to have a baseline data for at least my pico. Yeah, exactly, Dr. Khan. Yeah, you're right, subgroup. So what for subgrouping you have to kind of broaden your vision and set back and do not be laser focused. Instead, try to see it from a broad angle. But a good place to start is to start with a pico, like see if there is variation in your population, see if there is variation in the dose, see if there are differences in outcome definition. If all those three are justifiable, you can move ahead and read one by one study, and the in the discussion section most likely they will tell you what's causing this hetero, and then you can move from there. And another thing that you can do in the subgrouping is you can group these studies based on their risk of bias status. Let's say we have study A, which is the only study in which the methodology was not done properly, and this was a high concern study, and all the rest of the studies were low concern. So what I can do is I can pull these three together, and this one I can pull. Let's do it. Do you guys want to learn how to do subgrouping? Because that's not I was aiming for. We have to cover the writing session as well. So if I pull the high risk individually and then these individually, then that's a subgroup. How we interpret p-value in percentage, how much percentage there is a chance of. Yeah, so you see the 0 point is, this is how it happens. If it is 0.05 and if you divide that by 100, that's a 5% chance. If this is 0.0001 and then you divide it by 100, then it gives you the percentage. But you don't report it like that. You just mention this number. I is equal to 89. That's pretty high. So that's going to be significant anyway. When I remove this, see how this became 0.36. So 3% is telling me that, hey, this is non-significant. What to include in your result section, that we will discuss in detail moving forward. And now someone said how to do the binary. We will do that now. So I will again add the outcome. So I will click this asset IBU, but not the fever, because fever was the outcome right here. This is our main interventional groups analysis. So I will go and add outcome right here. And instead of continuous this time, I will add the dicot. And then let's name our outcome, which is fever recurrence. And now to used one is this risk ratio, inverse variance, random effect. That's different type of meta. This is comparison meta, so we have to keep it simple. Asset aminofen, and then favors ibuprofen, and nothing, finish. So now see how right here I have a fever recurrence, and now again I will add the study data. We have 4 studies to add again. Oh yeah, so here's the thing, someone in our data extraction, I gave some example regarding 20 outcomes or something. We still have it here. So what's happening in this study is that this study, let me name this study A because that's what we have been following. Study A. So study A reported fever recurrence, study B reported fever recurrence, C reported, D didn't report, right? So I can write NR, which is not reported, and leave it alone. So for analysis, okay, where's the RevMan? For analysis, I will pick these 3, 1, 2, 3, finish. And then I will add the, we already have the study in. So now I will copy paste. See, give me 1 second. I didn't copy these, did I? Copy. So first you select these and then you add Control V. And now Control V. So now we have a forest plot, and notice how we have a risk ratio here, and see how this number is 1 but not 0. Give me 1 second, I will be back. Sorry about that. So we have Dr. Ahmed in chat box saying, so study B is less significant and we will remove that. No, you will not remove anything on purpose to just to increase the significance. For leave one out, you will be leaving one study at the same time to see which study has the effect on the overall analysis, and then you will be transparently reporting this in your results that hey, we removed this study and the pooled analysis became more significant. You cannot purposefully leave a less significant study out because that is reporting bias. Let's say you want to do a meta and you have found 11 studies, and in 11 studies favored ibuprofen, oh sorry, 8 studies favored ibuprofen and 3 did not favor any group. What you did is, well, you only involved those 8 studies, and this is ethically very much wrong, and your paper will be retracted for this practice. You have to include everything and then report transparently what's happening. In this leave one out, we are only trying to figure out which study is causing this heterogeneity. In our case, study A was causing the heterogeneity, but we will mention that in the results. So this is the forest plot for binary data. This part right here is exactly what it looked like in our sheet. And then we have this risk ratio instead of mean difference. We again have this inverse variance, random 95% confidence interval. Is that? So notice the interpretation is still the same. The only difference is instead of 0, right here we have 1. And the USMLE people play with this a lot, and you kind of have to just remember that risk ratio, odds ratio 1, mean difference 0. If it crosses 1, it's not significant. In our case, all or these are non-significant, so our diamond is also crossing 1. This is supported by this right here, 0.78, then 79, 80, 90, and then 1. Crosses 1. This again crosses 1, 0.52, 53, 54, 56, and so on. Ultimately, it will reach 1, and supported by this as well. This includes 1. supported by p-value as well. So all three things are telling us, p-value, risk ratio, diamond, all three are telling us that hey, your results are not significant, and our hetero I2 statics in this case is 18%. We can go ahead and do the leave one out analysis for this and see if something happens. So if we remove study B, our hetero becomes 0, right? So we can report that as well. So now that we have these forest plots and we know how to interpret these, we will move on to result writing. I hope the forest plot interpretation is, if not everything is clear, something is clear. Let's download this. And yeah, so the most important thing is you will be given, as a beginners, maybe you don't have any projects now, but as you move forward, the research area is like really evolving, and trust me, you will have 50 plus projects. So what you want to do is you want to have your backup RevMan session. So you will click this button and then you will write in your project name and just make a folder for projects, and then you have to save all your analysis, because most of the time what happens is that you submit to general, they will give you back the manuscript and they will tell you that hey, change this or that, or maybe you put acetaminophen here, you didn't put it, that you put experiment favors control and your supervisor wants you to change that. So it's good practice to have a backup of this whole thing. And if I want to save just this forest plot, I will click this button right here, and then I can save it anywhere I want. For this one, I will save it on desktop. And then we will save leave one out as well. Oh yeah, I did the wrong thing. You see, you have to save. Let me. So LOO is short form for leave one out analysis. You have to save the PNG format right here, because that's what most of the time the journals will want. So I will save that in this.